Now, an example of Archimedes' principle, I'm looking at the textbook, page 10-16, and I'm looking at problem 16. So it's page 10-16. Problem 16. And this is an example problem for Archimedes' principle. And it says, and I have to read it twice, I always do, a piece of wood, so that's important, 10 centimeters long, 5 centimeters wide, and 2 centimeters high, floats on seawater with 7.7 centimeters of the height above the surface of the seawater. The density of the seawater is 1,025 kilograms per cubic meter. Calculate the density of the wood. Now, we said the water has a density of 1,000 kilograms per cubic meter, but that's fresh water. That's pure water. This is salt water, so it's more. So what we have to do, I'm going to use metric SI units, though. I'm going to use meters instead of centimeters. But let's make a little drawing first. This is what we have. We have a piece of wood like this, like that. And what happens is a certain percentage of it is above the surface of the water and the rest of it is below. So the length of this piece of wood was 10 centimeters long, that's 0.1 meters. And the width of it is about 0.05 meters. So it says here, it was 5 centimeters, so it's 0.05 meters. All right. And the actual height of it is 2 centimeters, which is 0.02 meters. Now the amount that's above the water is 0.07 centimeters. No, 0.07 meters. And the amount below the water would be 1.3 centimeters, would be 0.013 meters. Now I'm going to say that again because I think I've just confused you a bit. All right, the length of the thing is 10 centimeters, but that's going to be divided by 100, and that makes that 0.1 meters. And then the width was 0.05 meters, or 5 centimeters, divide that by 100, 0.05 meters. And the height of the thing is 2 centimeters, and that's 0.02 centimeters. Now this thing, what happens is about 0.07 is above the surface. It's going to be 0.7 centimeters, which is 0.007 meters above the surface of the water, and then the rest is below the surface. Now, since this thing floats, according to Archimedes' principle, the buoyant force, I'm just going to call it F sub B now, the buoyant force, it will be exactly equal to the object's weight. Because it floats. So F sub B will be equal to the weight of the object. All right? Now the buoyant force is equal to the density times G times the height. And I better think about that again. All right. So the density of the seawater is 1,025. Gravity is 9.8. And the height below the water is 0.013. Meters. Now I need my calculator to work that out. So let me get out my calculator. All right. gonna be 1,025 times 9.8 times 0.013 equals. And I made a mistake. So I'll try it again. 1,025 times 9.8 equals times 0.013 equals. And that comes out to be about 130 newtons. All right. Now, we want to figure out the density of the object. Well, the density of the object is equal to its density times its volume times G. Well, we know this is 130 newtons now. That's the buoyant force equal to the weight of the object. Well, the density of the object is what we're looking for. The volume of the object will be its length times its width times its height. Well, the length of the object was 0.1 meters. 0.1 meters. The width is 0.05 meters. And height was 0.02 meters. And then G is 9.8 meters per second squared. And this is 130 newtons on this side. Now when I work this out, we should get the answer that I have in the book, unless I made a calculation mistake, which is easy to do in a problem like this. So let's give it a try. We have 130 divided by 0.1 divided by 0.05 divided by 0.02 divided by 9.8. And I think I made a mistake, so I'm going to go back and try this one more time. All right. So 130 divided by 0.1 divided by 0.05 divided by 0.02 divided by 9.8 and I got an error which means my calculator is not working too good today. My brain's not working too good today. And so when I work this problem out, I should get 670. The density of the wood will be 670 kilograms per cubic meter. And that's the end of that problem. All right, let's shut that off.